Hi, what's going on, everyone? My name's Ryan. I am a principal product manager here at Grafana, one of the many hats that I wear here. I'm also one of the founders of Pyroscope, which is our continuous profiling platform. We're going to talk plenty more about all that later, but before we get started, obviously you have the Slido slide here. If you have any questions, feel free to ask throughout the presentation. We got a bunch of people talking today, so hopefully we will have time for questions, but if not, we'll be at the Find the Experts booth after, and you can ask us there. So yeah, we got a lot of people talking today, so I'm going to go ahead and get started. Obviously, welcome to ObsCon New York. We're on day 2. Hopefully, you all have had a chance to get out, explore the city, see New York a little bit. Just by show of hands, I'm curious, how many people is this your first time in New York? Okay, yeah, we got a lot of new New Yorkers. Anybody from outside the country? Oh, wow, that's way more than I thought. So a lot of international people as well. So yeah, again, welcome. I'm not from New York, but it is one of my favorite places in the world. I love the mix of cultures here, the fact that it's the center of so much culture, whether that's art, movies, TV, fashion, politics, like whatever it might be. A lot of that originates here in New York. And so, if you're interested in landmarks, obviously, we are here, there's a ton of really historic landmarks right where we are literally sitting today, but really any neighborhood you go to, you can find some interesting stuff there. If you're into sports, there's plenty of, sports to see. Almost so many, there's like 2 teams for pretty much every major sport. There's even a soccer team here. There's bars, music. I know a bunch of people, or a couple people went to a concert at Madison Square Garden. I don't see them here today, so hopefully they will, make it back later. But, my favorite food, like really just no matter what you want to do, a lot to do here. So my favorite rapper, who is also a New York native, said it's the concrete jungle where dreams are made of. There's nothing you can't do, including quote Jay-Z in your tech talk. So I bet you didn't have that on your ObsCon bingo card. It's kind of a double-edged sword, though. There's a ton to do here, but at the same time, that makes it really hard when you want to do something specific to filter through all the many options that you have to see something specific. This happened to me yesterday. All the Grafanistas here know how much I love pizza, and I wanted to find the best pizza in Manhattan, and I sort of had 2 options of how to go about it, right? And so option 1 was to, ask an expert. Luckily, I have a friend, Michelangelo, who, if you can't tell by his name, is of Italian descent. And if you can't tell by the profanity that the marketing team has so kindly blurred out of my presentation here, is also a native New Yorker. So he was the best expert that I could ask about pizza, and he was able to recommend me somewhere. It was really good pizza. If you get the chance to go there, try it out. But also, how many people in here have a Michelangelo in your life who you can ask about pizza in Manhattan? It's like 3 hands maybe out of the 300 people here, maybe the top % have access to that. And so for the other 99% of us, if we want to get our pizza fix, we have to find some other way to find that pizza. And so enter Google Maps, which I'm sure you've already used here so far, where you can filter by what's open now, what fits your price range, what's top rated, et cetera, and makes it accessible for the rest of us, right? And so, what does this have to do with Grafana? Well, our old Explore experience was kind of the main option, right? And so if you had an expert on your team who knows how to write PromQL, LogQL, TraceQL, FlameQL, knows how to write all these query languages, you could reach out and ask them, and they can tell you, oh, here's your problem, here's what you got paged about, here's how you fix it, right? But for the other, maybe they're on vacation, maybe they're asleep and you got paged in the middle of the night, maybe you just don't know who that person is, or maybe that person doesn't exist at your company, in which case, you have to find some other way to solve your problems. And so that's what we created all of these Explore apps, which is what we're going to talk about today, to make it easy for the other 99% of us who may not be experts in all these languages to still get value from all that telemetry data that you're collecting from your logs, metrics, traces, profiles, et cetera. And so enter our Queryless Explore suite is what you're going to see today. You're going to see a couple demos from metrics, logs, and traces. And then we have a special guest from Shopify who's going to talk about how they get value from their profiles. And so with that, I'd like to bring Catherine on stage to start us off with Explore Metrics.
Thanks so much, Ryan, for the intro. So I'm going to talk about Explore Metrics and Explore Logs. But before I do that, I want you to imagine this. It's Black Friday, and you and your team are getting ready for the big day. You're hoping your systems can handle the onslaught of customers, and things seem to be going smoothly, so you go to bed. However, you wake up and you're getting pinged. Your customers are seeing slow response times, your web pages are timing out, and you and your team is panicking. Now, looking at a video here, you might be using Grafana for metrics. And in general, you can probably narrow this down, but it can take some time. You know there's slow response times happening in your system, so maybe you're gonna look for a metric related to slow requests. And you start to query it, and you don't find a problem. So you look for another metric here. And it takes time, to query and look for other metrics. And once you get there, you might be able to find a metric that eventually shows a problem. And you get there, but there might be issues with, let's say, a CPU metric as well. So you repeat this process all over again. And let's not even talk about the upfront effort it took for you and your team to learn PromQL. So going back into the slides, with Explore Metrics, you're able to visualize all metrics from a Prometheus data source without having to write a single query. That means you can dig into each metric, making it much quicker for you and your team to perform an investigation, leading to much faster time to first insight. Now, I'm going to demo what that looks like. So as you can see here, there's a list of metric graphs on Explore Metrics, and you can scroll through them. You can also hover over some tooltips and learn more about the metric in terms of the description and type. You can also filter or search for metrics. You can filter, for example, if you knew it was coming in from Kubernetes, or if you know there was a container, it was coming in from a container. Now, in my case, I know that this customers have been seeing a slow response time, so I might want to look for a request metric. So I will search for that, and I know this has been happening, let's say in the past 12 hours. So I'll change for that time range as well. So I can see there's some metrics showing spikes here, so I'll go into one of these metrics. And I can see this graph again, along with a list of labels and some more information about the metric. I can also go into this breakdown tab, which shows a list of graphs related to the labels as well. Now, in my case, I feel like this problem might be related to an endpoint. So I can select this endpoint value, endpoint label, and then I can see these different values. I can see there's spikes showing up again for the login and payments. So I might want to add this to a filter. Now that I know that this is related to, let's say, an endpoint, I want to look at other related metrics that might be having problems too, and I can do this by clicking the Related Metrics tab, which shows metrics related by the string name. So I can click into another metric. I can take a look here. And once I finish my investigation, I may want to do other things, like, for example, I can bookmark this for later. I can share this investigation with a coworker, and I can also open this in Explore. So when I open this in Explore, you can see the query again if you wanted to manipulate this, or if you wanted to, for example, to add this to a dashboard. So this is Explore Metrics, and with this, you're able to find a problem. But what exactly is the actual problem? Well, this is where Explore Logs comes into play. So with Explore Logs, the challenges of looking for logs are very similar for the challenges of looking for metrics in Grafana. So looking at a video here, you can see that someone is trying to query again, and maybe you're able to kind of like find the data you need. So even if you're able to, let's say, understand that, hey, I know it's coming in from a service, it's really hard for you to be able to really like narrow down what to look for if you don't know, for example, like the fields or the patterns you're looking for in the log lines. So Explore Logs allows you to really streamline the process of identifying issues caused by high log volume. You're allowed to filter further, and you're allowed to really efficiently pinpoint problematic log lines through this. And Explore Logs works with all Loki data sources. So I'm going to demo Explore Logs as well. So this is Explore Logs. As you can see here, there's a list of services, and associated with each service, you can see essentially a graph showing log volume as well as a graph showing, like a table showing log lines. So I'm going to refresh this. And you can see now that there is a full graph showing all of the log lines. And as I'm scrolling through this, I might see something interesting with, let's say, the Mimir ingester service. So I'm going to go into here. Now, in my case, I might want to filter by labels. For example, in my previous demo, I saw that there was something happening in one of the specific endpoints. And while I don't see endpoints here, I might want to then look into, like, let's say, log patterns. And I can see that this log pattern is showing something really interesting with here, and there's some spikes. So I'm going to include this as a filter. Next, I'm going to go into fields. So fields are key value pairs for log lines, and I can see there's interesting patterns showing up with a lot of these different fields. But I'll go into, let's say, this tenant field, and I see that there's interesting patterns showing up with this specific tenant ID, so I will add this as well. Now that I added in some filters, I will go back into the Logs tab. Now, I can view logs in two different ways. The first is just looking at the log lines. I can expand this, and I can see a list of all of the fields and filter out or filter in some specific fields. Or I can look at it in a table format, which is really good for JSON formatted logs. So here I can manipulate columns. Here I can manage them in different ways, or I can even click on a certain field and then add it as a column. And then similarly to Explore metrics, you can then open this in Explore. You can add the query into a dashboard, or you can manipulate the query some more. But as you can see here, this query is quite complex, making it really hard for me to really be able to write out this log QL unless I actually knew, like, for example, the patterns I was looking for or these specific fields. So this is Explore Logs. So going back into the slides, as part of this launch, I will also want to announce that we are having support now for OpenTelemetry. We know that many of our customers are using OpenTelemetry to collect and instrument their data, and now you can use Explore metrics and Explore Logs to view your OTel-compatible metrics and logs. This is now available on public preview. So as a recap, with Explore metrics and Explore Logs, you're able to reduce time to first insight. You're able to reduce time to diagnose a problem, leading to significant time and cost savings for you and your team. So as a recap again, Explore metrics, Explore Logs is now available for GA on OSS and Cloud, and you can try this out today. And now I will pass it off to Joe, who will talk about Explore traces.
Awesome, thank you. Hello, hello. Hey everyone, thank you Catherine for the awesome Explore Logs, Explore metrics demo. Hope to follow that up with a Explore traces demo. I guess I'll hit forward here so we can see that yellow screen. And then we're going to go into a demo for Explore traces. Oh, there we go. Cool. Can we swap to the laptop? Thank you. Awesome. So Explore traces, we got to see a little bit of yesterday. Genvia showed us some basic capabilities here, how we're taking our tracing data and showing an aggregate to find errors and duration, slower traces. Today, I hope to show a couple more features that you didn't get a chance to highlight yesterday. In addition, I'm going to talk a little bit about some flows that I really enjoy using with this application, as well as talk about our philosophy a bit, why we chose what we chose, why we built this the way we did, like what we think is important about traces. So first of all, she talked about there's the red metrics here, right? We have rate, errors, and duration. And the app kind of revolves around these three and orients the user to, if you're choosing and looking at errors, to find erroring traces. If you're doing duration, to find slow traces. And then rate is meant to be more of like a general exploratory experience. You're just trying to learn and understand how your applications talk to each other. So I think this is the first superpower of tracing. It is the signal that teaches us how our applications talk to each other. And that's a really critical and important part of Explore Traces, and we'll see a little bit more of that in a second. So I'm going to share this flow with you for both duration and with errors. And we're going to go find some slow traces. We're going to use filters. We're going to use this root cause trick here. And then we're going to do the same with errors. And we're going to see a very powerful method of using this tool to go determine what is wrong in my system, what is bad thing is occurring right now, I suppose. So first of all, we're going to start with duration here. You see I have a heat map at the top. It's ranging from a couple hundred milliseconds up to a couple seconds. And down here at the bottom, I have a similar breakdown tab we've seen in all these Explore applications. And I can kind of click around. Oops, I did not want to exit full screen, though. We can do something different than that. Let's just do this right here. Ooh, double click. Yeah, we'll just be like that for now. And I could click on each of these attributes and try to figure out which of these attributes was correlating with my latency, right? Jen showed us this yesterday, and it's fantastic. It is this automatic way to, for all of the attributes in my traces, immediately find these correlations for us. We can visually scan these set of graphs here and determine very quickly which attributes on our spans are tightly correlated with our slowest traces. So we're also highlighting those, bringing those to the top. Here I can see this particular span name profile occurs inside that box at the highest level, the slowest traces most often. And then we can see some of these other options here are only below the box, location, so we're not concerned about these. We have a couple other that are kind of in between, avatar and contacts, but maybe we're not so concerned about this. We clearly have one of our endpoints that highly and tightly correlates with high latency, so let's go investigate that a little bit. I will click Add to Filters, and apparently I'm going to bring up the dictionary a bunch. Again, now that we've added the filters, we're looking at a subset of the data. We can scan down and visually quickly see that there's not much more information here. Nothing is really nicely correlating anymore with that high latency. I'm seeing a lot of even bars, and this is telling me that it's basically the same inside and outside the box. A very quick visual indicator that maybe we don't have a lot more to learn here. So we're going to go to this next tab, which is root cause latency. So this is going to show us from that profile endpoint that we identified as a slower endpoint using the filters. It's going to show us those spans in aggregate beneath profile that are pushing out the length of this call. So this is a couple thousand or a couple hundred traces. We're looking for a bunch of examples, and we aggregate those all together to show you one view, to show you very quickly what is occurring beneath /profile that is slowing us down and making, we should be slowing us down, and is something we should investigate. So I can kind of clearly see here I have a user service. The user service is actually doing the job of finding the profile. Perhaps we see a couple hundred millisecond spans there. But we also see this auth service, which is 3 seconds. So we can see visually very clearly that this auth service is a problem. We can jump into, now we're looking at individual traces that we were aggregating to create this aggregate trace, and maybe we can start building a story, an understanding of why this auth service is pushing out our profile endpoint. I can look here, now I know because this is synthetic data, but I can look here and there's an event, and if I look at all of my examples, I can very quickly see auth service is always this problem. This event, mutex acquire, is occurring late in my span. I probably want to spend some development effort on figuring out what the locking issue is in this auth service. So if you see the profile endpoint is low or very slow, your initial instinct may be, let's go look at the user service. It's the thing that services the profile endpoint. But with a couple clicks, we could very quickly, in the Explore Traces app, see that the auth service is actually the issue. We're going to go dig on that, actually, and determine what's wrong. So this flow is very important to me. Start with your comparison tab, filter down, find those attributes that are correlating, and then go from there to the root cause tab. That's going to dig deep in the trace. So again, that is the superpower of tracing. How do my services talk to each other? What causes what? True causal relationships, not just correlative relationships. Tracing tells us that, and that is an important element of our application. So real quick, let's kind of walk through a similar thing with errors to show you we can do this with errors as well. So similar idea, we're starting looking at all errors across everything in our system, all of our traces. Comparison, again, very quickly, is going to highlight those attributes on our spans that correlate with errors. Very easy to visualize this. You can immediately see these first few boxes have important information for us. These endpoints here in stock, item, these all seem fine. They're all green, no big deal. Clearly, we have one here. Location, oops. Oh, my bad, the tooltip froze. Yeah, purchase. Purchase is highly correlated to our error. So this purchase endpoint is clearly having some issues. As before, we're going to add the filters. As before, we can see clearly no more information available at this level. We can scan visually and quickly see this. And just like our latency just like our aggregate latency, we can do aggregate errors through our traces. So this is hundreds or thousands of traces aggregated together to determine the path of errors and very quickly and instantly show you this error at the edge, this error at the gateway / purchase, how many services down is the root error? How far down do I have to go? Is it 5? Is it 10 services? Where is the thing actually occurring that's bubbling up all the way to the top? This is the question tracing can answer, and I am very happy and very proud that we can do this in our Explorer Traces app. So here we can see a couple of options: purchase endpoint, cart service. Cart service is going to this database, and the database here is failing. So immediately we have some very good information. We have a failing database. It's impacting this purchase endpoint. We didn't spend 10, 15 minutes looking at a whole bunch of different applications to see what errors were correlated. We immediately were able to stitch together with our tracing data all the way to the root cause, this database issue itself. The final thing I would like to demonstrate here is the fact that tracing data is highly structured, right? So log data a lot of times is just a text string. Metrics, of course, are a bunch of data points. But tracing data has attributes, some attributes that indicate clearly what is occurring. Like, for instance, a database access span will often look the same no matter what application creates it, especially if you have a set of semantic conventions like with OpenTelemetry. So far we've only looked at full traces. Like, we've looked at an entire trace and we've determined where errors are and we've dug down into that trace. But because tracing data is so highly structured, we can look at any element of your applications across all of them. So I'm going to look specifically at database calls. These applications are using the OTel semantic conventions, and because of that, the tracing app can show us across all our applications what are our databases doing right now, because all those spans look the same. So we're going to aggregate that information instead of the traces themselves. So let's jump to our comparison tab. This is now across all databases in our entire system. This is showing us those attributes on our spans that correlate to the database failures. So we instantly should be able to learn things like what services are failing, what database calls are failing, what databases are failing. We should see these visually, and we should be able to jump to those databases and fix them immediately. So I can see this insert database. That's what we saw previously, was an insert. So that's the span name. I can kind of dig around here, individual database statements. I can see this insert is failing more than is succeeding. And I can even browse over here and see, oh, I have some other selects. Those seem fine. Those are all succeeding. I can see the exact service. It's highlighted for me so clearly because that red bar is so much larger than the green. And then finally, even the database name itself. So I can see, okay, I got this inventory database. It seems fine. The user's database, though, that one is the one having problems. So with this comparison tab, we were able to instantly correlate across all our databases, all our database accesses, and see the service, the database itself, the kind of operation that was failing. And we have a huge set of clues to now take to our database and go look at logs, go look at metrics. Are we undertuned? Do we have locking on a table? You know, what is causing this issue? I have so much information, and it took me maybe a couple minutes to determine that with the Traces app. Cool. So I think that's it from me. Thank you so much. Ryan Perry is now going to show us Explore Profiles, the latest and greatest telemetry signal. Take care, brother.
All right, I'm back. Yeah, so Explore Profiles, I'm not gonna go through a demo. I think you kind of get the idea of how these Explore apps make things much easier to, to get insights from your data, which is, what we intended to talk to you about. And I also wanna leave some time to, have our guests from Shopify come up and talk about how they get value from profiles. But before I do that, profiling is a somewhat newer signal relative to metrics, logs, and traces. And so I do want to kind of take a second to sort of explain how profiling kind of fits into the bigger picture along with the other telemetry signals that people have. And so the example I usually give is that, when you have a hammer, everything looks like a nail. If you're just using metrics, if you're just using logs, you're going to find a way to solve every problem with metrics or logs. But a lot of times, similar to how you use actual tools in a toolbox, there's a better tool for the job. And so, a lot of people think of, first I start with metrics, and then I do logs, and then I do traces, and then I do profiles. But in reality, they're all kind of useful in different scenarios, and it's not exactly a kind of sequential, motion to use those. And so this slide kind of just shows a little bit of what that looks like. So for example, let's say you have a spike in your CPU metrics. That's useful knowing that something is going wrong there, but now someone's going to get paged. Maybe you have an alert based off of that spike. Maybe it's outside of a threshold. At some point, you're going to need to understand, okay, what do we do about this spike? How do we make our CPU go back down? Same thing with logs. Maybe you have an out-of-memory error that is showing up in your logs. Maybe you found it via the Explore Logs app, and now you need to resolve that issue. You need to drill down into somewhere and see that code-level root cause of what's causing that. And similarly with traces, maybe you've used Explore Traces, you've determined that some code issue is the reason that your trace span is slow. Again, you need to go change some code somewhere in order to make things right. And so that's where profiling comes in and is very useful at giving you that code level root cause of why something's going wrong and how you can then fix that issue. And we have spent a lot of time focusing not only on the Explore Profiles app, which again is very similar to what you saw with these other three, but also making it so that profiles can be kind of inserted and easily shown within your traces or linked to from your metrics or logs or anything else that you're using with your load tests, et cetera. So the thing I want to talk about too, just since profiling might not be as familiar, is kind of what the business value is. And so there's sort of three areas. There's you have the proactive side of things and the reactive side of things. One thing that we found to be very useful with profiling is that you don't have to wait till something goes wrong in order to get value from your profiles, right? You can already kind of understand, particularly in the cost-cutting scenario, and then often as well, even though latency here is in the reactive section, you can also do that proactively as well. If you have some initiative to make things run faster, profiling is very useful, for those use cases. And so, just an example of what that looks like. Some of you may have seen a similar slide to this before. In the past year, we've had a lot of customers sort of onboard onto our profiling product. And what we've seen is that a lot of times in the past, costs were less. As time goes on and as your company grows, costs tend to grow. And so, with just like a minimal amount of overhead, we often see, something like 10% of just like low-hanging fruit, easy costs that you can optimize in your infrastructure in order to, get value and get a good ROI on your profiles, again, before anything goes wrong or before you even realize that something's wrong. Perfect example of this is actually a company that I used to work for, but yeah, basically they were using a bunch of Kafka queues in order to do a bunch of jobs, right? And so this was a huge part of our infrastructure, and they were basically able to use profiling to understand that there was essentially a part of the compression code that by default was set to the maximum level of compression. And so what they didn't realize was that by simply adding an actual like variable there instead of using the default compression. That took it from using a significant amount of CPU to compress things to a much, much smaller amount, which ended up saving 20% on the AWS like compute bill for this service in particular. And that's a huge win. And again, that's the type of thing that you don't realize that a lot of this kind of bloat has crept into your systems until you're using profiling. I don't want to go through what is a profile, but if you're interested in like what the actual output of profiling is, how flame graphs work and stuff, feel free to come by to the Ask the Experts booth. I want to make sure we have plenty of time to talk about everything else. But yeah, this is the Explore Profiles UI. I just want to show this just because similar to what Joe showed with this sort of like baseline and comparison workflow, this is how you would understand, for example, what is the difference between a healthy period before something went wrong and then an unhealthy period after something went wrong. You get this output that shows you sort of in green the good stuff, in red the bad stuff, and what code you should look at in order to resolve that. And so talked a little bit about that. Elijah is about to come on from Shopify, one of our customers who has been using profiling very effectively. And he's going to tell you a little bit more about how they use profiling at Shopify to resolve some of their performance issues.
Cool. Thank you. Cool. I'm Elijah. I work at Shopify. Just with a quick show of hands, how many of you have purchased a product from a Shopify merchant within the last year? Cool. It's about as many as I actually expected. Shopify is the platform behind a lot of the merchants that you might shop on in North America and around the world. So we have millions of merchants across 170 plus countries. 10% of US's e-commerce goes through Shopify, but we're in the background typically. Cool. So profiling, why does it matter, right? Black Friday, Cyber Monday last year, 145 billion requests, 60 million requests per minute, 4.1 billion in GMV. So a minute of downtime for us can mean up to 2.85 million lost in GMV for our merchants. So at Shopify, performance is critical for us, maintaining that reliable user experience for many of our shoppers. And in a large platform like us, issues around latency or CPU, they can have a real impact across millions and millions of requests. So we really wanted to find a solution that allowed us to understand at a more granular level what is performance like for Shopify. Cool. So the challenge before Pyroscope, what did it look like? Shopify is our core app is a Ruby monolith. And so before we start using Grafana profiles, we face challenges around like, how do we monitor this thing? We have this really large fleet of machines. And our solution at the time was you kind of put in this header and that header will kick off a profile for the given request, and then you get that profile and look at it in SpeedScope. But like one ad hoc request does not tell the whole story. And so something that we wanted was to be able to look across the fleet, across all of our processes, and understand how they were performing. In addition to that, things like Google Cloud Profiler just simply didn't scale for us. Cool. So what's the shift? Well, the shift started about 3.5 years ago. I came to Shopify. We built our own internal observability product we call Observe. It's on my shirt. But that's built on Grafana, and we use open source Grafana. So we built our own metrics, we built our own logs, and our own tracings product. And we had a small team of about 3 people looking at profiling. And this kind of speaks more to that big tent mentality that Grafana has. We were able to use open source Grafana and connect it with Pyroscope to do profiling. And so what this gave us was that granularity, the ability to dive in and look across all of the requests aggregated across Shopify Core, our monolith. Cool. So what does that look like, right? And what does success look like for us? At Shopify, we have a saying, not all software is great, but all great software is fast, and we really care about that. The faster we can render our sites, the faster we wanted to make it easy for people to check out. So we actually do it 1% at a time. And we just iterate, right? So little changes across a fleet like ours make a big impact. So on CPU, we've done this multiple times where we'll have 1%, 2%, 5%. We've even seen up to 20% wins just by looking across the fleet, digging in and finding where we're spending time in GC, as well as allocations. And so speaking of allocations, Ruby's garbage collected. That means we do a lot of allocations, which means if we can reduce the amount of allocations we have, we also reduce the amount of time we spend in doing garbage collection. And then on the front, we use Ruby on Rails. We're proud that we are a monolith, like I said, but that's built on open source components. And so anywhere we can optimize the Rails apps or make contributions back there, we can then roll that out across Shopify and reap the benefits of those optimizations across all of our apps. Okay, so so PowerScope actually, for a CPU, we saw a lot of performance benefits that just from analyzing across thousands of requests. So before we could not look at what was this given controller and this action doing, and now we can do that across any controller at Shopify, across any app, across our entire fleet. And so that drill down allows us to dig into places and optimize them. Specifically, one of the things that we were able to optimize was aggregating the StackProf's object profiles in Ruby. We were able to reduce those, and then that reduced the amount of allocations, which meant we were able to reduce the amount of garbage. And then taking that, we're able to roll that out across all the Ruby apps at Shopify. So then the performance profiles got a lot better across Shopify, which actually translated into an actual performance benefits for more reliable checkouts. And then here you can see these are actual contributions we've made back to the open source and back into Rails using optimizations that we found from PowerScope. So things like Active Record. Internally, we use StatsD to measure a lot of our internal clusters. So that's our protocol. We migrated from a vendor that emits StatsD. I'm not going to name them last year. However, one of our core apps emits a lot of metrics, and these metrics grow with time. And we found just by connecting PowerScope and looking at the profiles, an optimization that led to a 20% CPU reduction across our entire fleet. So, yeah, I'll just show this really fast. We have many apps at Shopify and that are written in Ruby. We have our own profiles processor. This is kind of how we do it. And takes the Ruby profiles, transforms them to pprof, and writes them to PowerScope. Observe, again, that's our open source in-house built Grafana observability tooling. And our developers get to just come in. And then one of the best things for us by enabling continuous profiling across all of our applications is now that engineers don't have to think about it, right? They don't have to go how do I get the profile for this thing? We just do it automatically. And that was a big win for us. And so now they can focus in on going to find the optimizations and hunting for places to improve. So last thing I'll say here, one of the engineers on my team or at our company focused on efficiency. Once we got continuous profiling on, says, I have no idea how I did my job before continuous profiling. And so just want to shout out, thanks PowerScope. It's been really awesome to work with this team, as well as the 3 engineers that do all of this work for us at Shopify. And so, yeah,